right, guys, here's your test review for your test tomorrow. Solving problems with exponential equations review. All right, these formulas are on the test tomorrow. Let's talk about them for a second, though. First one, the basic exponential function. There are no percentages. If there are no percentages, you use the basic function. Now, what you do have to study and memorize is in this formula right here, y equals a times b to the x over t. X is the total time. T is the time it takes the base to repeat. So if it says something doubles every 2 hours, 2 would be your t value. Because after that, it's going to ask you how many of that item would be there after 3 days. So 3 days is your x value. And you got to convert 3 days into hours. So do 24 times 3, get 72. Okay, but the basic one is when there's no percentages. That's when it's telling you it's doubling, tripling, quadrupling, halving. Okay, these other types, the growth, decay, and compound interest, have percentages. The first one, 1 plus r to the t, that's an increase, a growth. 1 minus r is a decrease, a decay. It'll have a percentage. Now over here, the compound interest, it will say compound. And again, it has a percentage, but it's going to say compound. If it says monthly, remember that means n is 12. If it says quarterly, that means n is 4 quarters in a year. If it says semi-annually, that means that n is 2, and if it says annually or yearly, that means n is 1. Okay, so the n value changes based on how it compounds, but it will say compound. Make sure that you write all this down so when you study tonight, you have that to look at. So everything I've added right here, make sure you write it down. Again, the formulas are on there, but you got to know which one to use. Okay, and tomorrow on your test, you're going to be asked questions like, what formula would you use? And you have to pick the correct one. You don't solve it, you just pick the correct one. Or it might say one part of the question is, what formula would you use? What's A? What's R? What's N? What's T? Now plug them in and solve. Okay, so you have to know what all that stuff is and what it means. So let's look at number 1. Jack purchased a diamond ring for his wife 20 years ago. There's a number right there, 20. For $500. There's another number. The value of the ring increased by 8% each year. What is the value of the ring now? Increased and a percentage. It doesn't say compound, it says increased and a percentage. So the formula that we are using is y equals a times 1 plus, since it's increased, r to the power of t. And on this one, our a, or our starting value, is 500.
Coach Lewis, please call Ms. Matthews. Coach Lewis, call Ms. Matthews. 137. Thank you.
The r value, the rate here, is 8%. So we divide that by 100, and we get 0.08. That's what we're going to plug in, is 0.08. And the time is 20 years. So t is 20. We get that because he bought it 20 years ago, and we want to know the value now. So 20 years has elapsed. So we're going to take those 3 items and plug them in. So we got y equals, a is 500, times 1 plus 0.08, not 0.8, 0.08 to a power of 20. So go ahead and type that in. And remember, this is a money equation, so round to 2 decimal places. This is talking about the value. That's monetary. and you type it in, you get $2,330.48. It is very important that you know what formula you are using and what each one of the letters represents. You want to write that down. If you got the review Friday and you did it and you didn't write that stuff down, write it down and study it. All right, number 2 has 2 parts. So both of these lines, this line and this line, go with number 2. A deposit of $7,000 is invested at an interest rate of 3.5% per year. Find the amount in the account after 3 years if interest is compounded monthly. We know right now we are using the compound interest formula because it says compound. So we're using the formula y equals a times 1 plus r over n to a power of n times t. So, in this example, we need to know all these different letters. Well, the a value is 7,000. That's what was initially invested. The r value is 3.5%, which when we divide that by 100, we get 0.035. So that's what we're going to plug in for r. The n value is 12 because it says monthly. And then in n times t, we're going to put 12 times 3 because t is time and the time up here is 3 years. So remember, the exponent is n times t. We're putting 12 times 3 up there. Okay, I'm going to erase this, so make sure you have what everything is written down because now I have to plug it into the formula and solve. So if you need to pause, and write it all down. All right, so now we're going to punch all that information or write all that information in our formula and then punch it into our calculator. Now, you got a little more room on your sheet of paper, I think, than I do right here. So, here we go. We got y equals, the a value is 7,000 times 1 plus the r value is 0.035, not 0.35, 0.035. And this is monthly, so it's over 12. And the exponent is 12 times 3 because it's n, which is 12, times t, which is 3. And again, this is money, so when you punch it in, round to 2 decimal places. Go ahead and do that. All right, when you punch it in, you get $7,773.79 when it's compounded monthly. Now, the second part of this is find the amount in the account after 3 years if the interest is compounded quarterly. So the only thing that changes from the a, the r, the n, the t is now n, instead of 12, n is 4 because quarterly means 12. So we're using the same formula. We're still using the fact that a is 7,000, r is 0.035, but now n is 4, and n times t is now 4 times 3. That's the only difference. So we'll go to plug them in. Y equals 7,000 times 1 plus 0.035 over 4 to an exponent of 4 times 3. And again, punch it in. We're talking money here, so round to 2 decimals. All right, you get 7,773.79 $771.42. All right, let's go to the next example. Example 3. Your baby brother has an ear infection. The doctor said there are probably 50 million bacteria in his left ear. The penicillin the doctor prescribed will kill half of the bacteria every 7 hours. How many bacteria will be in your brother's ear after 1 day? A lot of numbers here. What I do not see are any percentages. So if you look at the top where we wrote no percentages, we're at the basic exponential function. And since it says every 7 hours, we're using the one with the fraction. So we're using this formula. Write it down. Y equals A times B to a power of X over T. And remember up there it says X is the total time, T is the time it takes to repeat. So A is what we start with. That would be 50 million. B is our rate of growth or decay. And this is decaying. It's being cut in half every time. So half is the B value. X is our total time. The greatest amount of time in this problem is 1 day. But we're going to convert that into hours. 1 day is 24 hours. And then the time it takes to repeat is 7 hours. We converted the day into hours because the time it takes to repeat is in hours. So now we can take those 4 items and plug them in the equation. Y equals 50 million times 1/2 to a power of 24 over 7. Now, bacteria, you won't have half a bacteria. So let's just round to the nearest whole number on this problem. So punch it in, round to the nearest whole number. Remember, to get these fractions, you hit math, left, enter. So the correct result here would be 4,643,732. Okay, now this is a big number problem. So let's make sure that that's correct. Let's go back and check real quick. We have 50, 1, 2, 3, 1, 2, 3, 50 million times, math left, enter, 1 over 2 to a power of, math left, enter, 24 over 7. 464, 373, 2.15. So 4,643,732 bacteria is the correct response. Never hurts to check twice. All right, if you flip it over to the back to number 4, Melanie purchased a car for $23,000 in the year 2014. The value of the car depreciates. That is a word for decay at a rate of 20%. How much will the car be worth in 2020? So the formula that we are using right here is decay. Y equals A times 1 minus R to a power of T. Minus because we are decaying. The A value is what the car started out at, $23,000. The R value is the rate of depreciation, which is 20%. Divide that by 100, get 0.2. That's what we'll be plugging in for R. The T value is the time from 2014 to 2020. Well, if you subtract those dates, you get 6 years. So we're going to take those 3 numbers and plug them in. We got Y equals 23,000 times 1 minus 0.2 to a power of 6. Make sure you put 0.2 and not 0.02. punch those in. Again, this is value in money, so you want to round to the second decimal place. So when you type it in, you get $6,029.31. And again, we wrote it like that because it is money. All right, moving on to number 5. The foundation of your house has about 1,200 termites. The number of termites doubles every 8 hours. How many termites will there be after 2 days? Again, it's another one with a lot of numbers. But what I do not see are percentages. So I know I'm using the basic exponential function. And since it doubles every 8 hours, I have to use the one with the fraction exponent. Y equals A times B to the power of x over t. My A value is where I start. It's 1,200. My B value is 2 because it says my growth rate is that the termites are doubling. X, my total time, is 2 days. But I want to convert that into hours. So 2 days is 48 hours. And my T value, or the time it takes to repeat, is 8 hours because it says that the number of termites doubles every 8 hours. So now it's up to me to plug these 4 numbers in to find out how many there will be after 2 days. So Y equals 1,200 times 2 to the power of 48 over 8. We'll punch it in, and again, these are termites, so let's make sure it's a whole number, and I think this time it is a whole number. So punch it in, see what you get. All right, when you punch it in, you get 76,800 termites. All right, swapping gears for a second. Let's look at a problem where we're going to graph an exponential, and then we're going to name its characteristics. So on your calculator, it says create a t-chart and graph the exponential. Use your graph to identify the following characteristics. Well, what we need to do here is hit y equals, and then y1 we're going to hit left parenthesis, math, left, enter, so we can type in that fraction 1 over 2, right parenthesis, and then to get the exponent up here, we have to hit the caret button, which is right above division, and then we hit the letter x, which is right next to alpha. Once you have it typed in, if you want to make a chart, a graph, like this one here, you would hit second graph, and it brings up a table. Now I've already given you some x values, starting at -2. You got to fill in the y. When x is -2, it says y is 4. When x is -1, it says the y value is 2. When x is 0, y is 1. When x is 1, y is 1/2. Or you could just write that as 0.5. So either way there. And then when x is 2, y is 1/4, or again, that's 0.25. Okay, so that's what your table should be filled out with. Now, you can see that there's more points there, like the point -3, +8, that's on there. Okay, but obviously I didn't give you that on the table. Now we're going to take this table of coordinates and plot the points so we can draw a graph. So our first point was at -2, 4. So that tells me to go left 2 and up 4 spots. Now remember I said just a second ago in your calculator, there was also a point at -3, +8, so you could put that point in if you wanted to. But -2, +4 is the first one that was in our chart. And then there was a point at -1, +2. That means go left 1 up 2. Then there was a point at 0, 1. So start at the origin, go up 1. There was then a point at 1 and 1/2 or 1.5. That would be right here. And then at 2 and 1/4 or 2 and 0.25. Now, before you connect the dots, on your calculator, hit the button that says graph and watch it draw the picture. And on your calculator, it draws it from this angle right here. It comes from the top, comes down, curves, but it never touches the x-axis. I know it looks like it does, but it never does. Now, make sure that you put these arrows on the end of it. All right, and while we're on the point right here, it comes down and it curves at the x-axis. So that line, that horizontal line right there, is the asymptote. And remember, for the asymptote, we tell what the y value is. And at the x-axis, or at that point right there, the y value is equal to 0. And the asymptote is important because we use it for the range and for the end behavior. We use it for the range and the end behavior. So let's start back up here at the top with our domain, range, and all that. The domain should be the easiest piece of this whole thing because with the arrows on the two ends of the graph, the domain is always -infinity to +infinity. Always. With arrows on the left, arrows on the right, the domain goes from -infinity to +infinity. The range starts at the bottom of your graph. And at the bottom of the graph, we have the asymptote. And the value of that asymptote is 0. That is where the range begins. Then your graph moves up, and up here at the top, you have an arrow that is pointing up. So that tells me that the range goes to +infinity. It starts at 0, goes to +infinity. The reason there is no bracket in front of this 0 is because our graph never touches 0. It approaches it, but never touches it because that is the asymptote. Now, x-intercept. Since the asymptote is y equals 0, which is also the x-axis, there is not there is not an x-intercept. So for x-intercept, we write none. Y-intercept, on the other hand, we do have one. There's two ways you can do it. Because you made a table, you could look to see where the x value is 0, and that point is your y-intercept. Or, on the graph, you can look at where this red graph touches the y-axis, and that's right here at the point 0, 1. So the y-intercept is at 0, 1. Remember, for the y-intercept, the x is always 0. Now, as far as a minimum and a maximum go, there's no minimum and there's no maximum because there's not an absolute stopping point at the bottom or the top due to those arrows. Now, end behavior. Again, we have two ends. There's a left end and there's a right end. On the left-hand side of the graph, all of the x values are moving to -infinity. And on the right-hand side of the graph, the x values are moving to +infinity. Now, if you look at the left-hand side of the graph, you notice that the arrow on the left is pointing up. So that means that on the left, the y's are going to +infinity. On the right-hand side, the graph is flattening out at the asymptote, so that means the y's are moving to the asymptote, which is at 0. So your end behavior is as x goes to -infinity, y goes to +infinity. And as x goes to +infinity, y goes to 0. on this graph, if you start over here on the left and move along the graph, you're going down or decreasing. So we would circle decreasing, and remember this interval of decrease or increase is the same as the domain. So you would say from negative infinity to positive infinity, we are decreasing. Now the last thing it tells us to do at the bottom is find the rate of change over the interval -1 to 2. Remember, in interval notation, these numbers are x values. Your formula for rate of change is m equals y2 minus y1, or subtract the y's on top, over x2 minus x1. So what I would go ahead and do, since I know -1 and 2 are x values, I'd put them on the bottom, -1 minus 2. And the best thing to do here is to go back to the chart. All right, when x is -1, the y value is 2. So the first thing you put on the top is a 2, because when x is -1, y is 2. And then you look at the other one. When x is 2, the y value is 1/4 or 0.25. So when x is 2, you would have minus 0.25. All right, so the y values that go with -1 and 2, the y value with -1 is 2, the y value with 2 is 0.25. So we're going to punch this in our calculator. We hit math left enter, 2 minus 0.25 on the top, -1 minus 2 on the bottom. As a fraction, let's see here. So we hit math left enter. On the top, again, we 2 minus 0.25. On the bottom, -1 minus 2. And as a decimal, we get negative 0.58, and the 3's repeat. So that would be your rate of change from -1 to 2 on this graph. You might have gotten -7/12. That'll work as well. Okay, but -0.583, or if you'd even put -0.6, that's fine. Okay, just make sure that you read the questions on the test tomorrow, because when you're doing these word problems, it's going to ask you for the formula that you need. That's why I wrote it down on all of these formulas right here that you needed. Make sure that you look at the questions tomorrow on the test, and good luck.